Alright, we're going to troubleshoot what's commonly called an ice cube relay. Now sometimes these are shaped like an ice cube, about the size of an ice cube, and most of these you can see the components through the case. Now what I've done is I've removed the cover from this one so you can see the components, but if you look at this schematic symbol, you can see that it's a 24 volt relay, which means you have to apply 24 volts to this relay to get these contacts to move. So this is the coil portion of the relay, so we're going to apply 24 volts to that coil, and these contacts should flip-flop states. So there are 4 sets of contacts in this particular relay, and if we look closely here, between this contact and this contact, those would be what's considered the normally closed contacts. If you energize the coil, then these contacts are going to flip states, so the normally open contacts will close, so then continuity will flow between this contact and this contact. So I've taken the cover off of this relay to show you the components. So if you look at the bottom of the relay, these 2 leads would be the coil, which apply 24 volts, then the coil will energize, and then these are the contacts in the relay. So between this terminal, wire comes up to this contact, and this terminal, these are the normally closed set of contacts. And between this terminal and this terminal, those would be the normally open contacts. So we're going to apply 24 volts to the coil, and sometimes you can hear these click, and sometimes, again, if they're a clear case, you can watch the contacts actually move. So let's apply 24 volts to the coil. So I'm just going to apply 24 volts to these 2 terminals here, which is the coil. And listen, you can hear the contacts change states. And you can actually see the contacts move. So if we take and energize the coil, and now we'll have continuity between the normally open contacts, which are now closed, de-energize the coil, those contacts are going to flip-flop states, and this will go back to the normally closed contacts. And then again, the normally open contacts are open because we de-energize the coil. Now that's how you troubleshoot one of these type of relays. Again, you can see the coil, you can see the contacts pretty clear here. This is another style of relay, but the same principle applies. You've got the coil portion, which is 85 and 86, and if you look between 30 and 87 alpha, these would be considered normally closed contacts, and between 30 and 87 are normally open. So on the bottom of the relay are the contacts. So here's 85 and 86. So here's the coil, and then here's the common, which is 30 and 87A. So these would be your normally closed contacts, and these would be your normally open contacts. So the same rule applies. If you apply 24 volts to this coil, you can hear it clicking, which again means between pins 30 and 87 should be closed. Remove the current, and now 30 to 87A should be closed. So that's how you troubleshoot an ice cube relay, or sometimes these are called a Bosch style relay because these are actually manufactured at one time by the Bosch people.